Welcome to the chapter on basic electronics. In this chapter, we will cover some fundamental concepts in electronics that are essential for any first-year electronics engineering student. In this chapter, we will cover Ohm's law, Kirchhoff's laws, and various circuit components. Ohm's law is a fundamental principle in electronics that relates the voltage, current, and resistance in an electrical circuit. It is expressed by the equation V equals I times R. Here, V is the voltage across the resistor in volts, I is the current flowing through the resistor in amperes, and R is the resistance of the resistor in ohms. Consider a simple circuit with a 9-volt battery and a resistor of 3 ohms. Using Ohm's law, we can calculate the current flowing through the circuit. The current I is equal to the voltage V divided by the resistance R. So I equals 9 volts divided by 3 ohms, which equals 3 amperes. Therefore, the current flowing through the circuit is 3 amperes. Kirchhoff's laws are two principles that deal with the current and voltage in electrical circuits. These laws are essential for analyzing complex circuits. Kirchhoff's current law states that the total current entering a junction in a circuit is equal to the total current leaving the junction. Mathematically, it can be expressed as the sum of currents in equals the sum of currents out. Consider a junction with 3 incoming currents, I1 equals 2 amperes, I2 equals 3 amperes, and 1 outgoing current, I3. According to Kirchhoff's current law, I1 plus I2 equals I3. So 2 amperes plus 3 amperes equals I3, which means I3 equals 5 amperes. Therefore, the outgoing current I3 is 5 amperes. Kirchhoff's voltage law states that the sum of all voltages around a closed loop in a circuit is equal to 0. Mathematically, it can be expressed as the sum of voltages equals 0. Consider a closed loop with 3 components: a battery of 12 volts, a resistor with a voltage drop of 4 volts, and another resistor with a voltage drop of 8 volts. According to Kirchhoff's voltage law, the voltage of the battery minus the voltage drop across the first resistor minus the voltage drop across the second resistor equals 0. So 12 volts minus 4 volts minus 8 volts equals 0. Therefore, the sum of the voltages around the loop is 0, satisfying Kirchhoff's voltage law. Electronic circuits are made up of various components, each serving a specific function. Here are some of the most common components: resistors, capacitors, inductors, diodes, and transistors. Resistors are components that resist the flow of electric current. They are used to control the current in a circuit. The resistance is measured in ohms. Capacitors store electrical energy temporarily and release it when needed. They are used in filtering applications and for storing energy. The capacitance is measured in farads. Inductors store energy in a magnetic field when electric current flows through them. They are used in filtering applications and in tuning circuits. The inductance is measured in henries. Diodes allow current to flow in one direction only. They are used for rectification, which converts alternating current to direct current. Transistors are semiconductor devices used to amplify or switch electronic signals. They are the building blocks of modern electronic devices. Consider a simple series circuit with a 12-volt battery, a 4-ohm resistor, and a 2-ohm resistor. To find the total resistance and current in the circuit, we can use Ohm's law and the concept of series resistance. First, calculate the total resistance, which is the sum of the resistances, R1 plus R2. So 4 ohms plus 2 ohms equals 6 ohms. Next, calculate the current using Ohm's law. The current I is equal to the voltage V divided by the total resistance R total. So I equals 12 volts divided by 6 ohms, which equals 2 amperes. Therefore, the current flowing through the circuit is 2 amperes. By understanding these basic concepts and components, you will have a solid foundation for exploring more advanced topics in electronics engineering. Thank you for watching.